Welcome back, everybody. Mr. Renneker here. In today's lesson, we are going to learn about finding the area of circles. By the end of the lesson, we'll have the following main objectives. We're going to find the area of a circle given its radius or diameter, and you'll be learning about the formula that's going to be helpful in doing that. Let's go ahead and get started. First, let's do a brief refresher on what area actually is. If we were to have a polygon such as this rectangle here, we know that calculating the area would actually be asking us to measure the amount of space that a two-dimensional object covers up or that would cover it. You've learned a lot of formulas in the past about how to calculate area by multiplying various things together, but ultimately what we're doing is counting each one of the little squares or square units it would take to cover something up. Now, as I've started doing here, we can certainly count each individual square unit to find out how many total square units would comprise the area. But you found in the past that we could also use certain patterns, such as taking the length times the width to find out what a total area might be. Now, again, we use these square units like square centimeters, square feet, square miles, other things like that to count that because squares fit together very nicely. There's no gaps or overlaps left over. And so, again, in a polygon like this, counting those number of smaller squares that fill it is pretty straightforward. However, when we get to a circle, there are some obvious disadvantages. As you can see here, there are quite a few different squares that would be contained inside of a circle where the entire square is visible and quite easy to start counting. However, once we get to the outside of the circle, we can obviously see that entire squares are no longer contained, and it'd be very difficult to calculate by hand the amount of that square that is actually inside of the circle, making it very challenging to find the area. That's why we're going to need a formula here that'll help us calculate the number of squares or square units that are inside of a circular region. And while this will be a very brief demonstration, we are going to dive a little bit into where does the formula come from and why does it work? How does it help us find area? What we have to keep in mind is what are the dimensions of of a circle that we actually can measure, which of course would be its diameter, the distance running across the center of a circle from edge to edge. Or also we could measure the radius. And for this example, we are going to use the radius. And from there, we're going to use that to start counting squares that we know about. Now, if I were to draw another radius line, going straight up instead, what we start to see is a right angle formed here. And if we continue to extend these radius lines, what we actually get is something called a radius square. A square is a polygon. It's very easy for us to count the area of, or to use a formula like length times width. Whether you want to start counting individual squares, or multiply the side lengths together, we would find out after a few brief moments that the area, for example, this radius square is 16 square units. If we continue drawing those squares around the rest of the circle, we simply get a repeat of those various squares, all in this example covered by 16 square units. And ultimately, if we were to calculate this area, we just have 16 square units times 4 of these radius squares, and we'd have that total area of 64 square units. And that's wonderful, again, except for the fact that not all of those 64 squares are actually contained within the circle. So our question is how much do we actually take away from those 64 squares so I can find the area of the circle itself? Well, we can clearly see that it took 4 radius squares to actually cover the circle. That's where we got our 64 square units from. So let's take a look at each individual radius square. We've got the green one here. And when I look at the green shaded part that's not in the circle, it looks like we're taking just a little bit less than a fourth of the square away. When we look at the red one over here, same thing, just a little bit less. So not quite a fourth isn't inside the circle, so we're going to take that away. And the same thing here, and the same thing over here. So of course, notice I said it's about a fourth, but it's actually not quite a fourth. So when we go to take away some of these squares, what you could do is add up a fourth plus a fourth plus a fourth plus a fourth. Of course, that's 4/4. But I said, not quite that much. Because of the curved edges around the circles here, it's not a perfect fourth. It's not inside. It's a little bit less. So instead of taking 4/4 or one whole square away, we're going to take just a little bit less, and I'm just going to roughly call that about 0.9. That's pretty close to one whole square. So it took 4 radius squares to cover the circle, and we're going to take away the parts that aren't actually inside of that circle, which is about what we're going to call 0.9 squares. Then we'll take our original 4 squares. Again, that's the green, the red, the purple, and the orange ones you see here. 4 squares. We're going to take away about the 0.9 of them that's shaded in, the ones not inside of the circle. And that leaves us with roughly 3.1 squares, radius squares, that are inside of the circle. Now, that 3.1 should hopefully be a familiar number, at least really close to a familiar number for us, because you guessed it, that real number, since we estimated here, the real number is actually about 3.14, better known as about pi radius squares. And that leads us to our formula. The area of a circle is the product of pi, the number of radius squares we just counted, and the square of the radius. So we actually saw radius squares, but to find that area, what we actually did was we took the radius, one side length, times another radius, which is actually equal to what we'd say is a radius to the second power, which is what you see here in the formula. So just like you see in the algebraic version, I'll write it a little bit larger. The area of a circle is simply pi times radius squared, which means that if you know, or if you can find the radius of a circle, you've got all the information you need in order to find its area. Let's take a look at some examples. All right, in our first example, it says find the area of the circle. It does ask us to use a specific version of pi, which we'll review here shortly. So in order to find the area of a circle, we'd go ahead and start by writing out our formula. And then what we're going to need to do is either locate or calculate the radius of the circle. We're going to substitute it in for r in our formula, and we should be able to, with a calculator's assistance, find the total area of the circle. Well, in our image here, we do see that they gave us the radius, so we don't need to actually try and find it. It is 7 centimeters, and we should be able to take pi times 7, and again, the radius must be then squared. We need to simplify that. We're going to go ahead and take 7 squared. Remember, r squared is the same thing as r times r, so in this case, if it's 7 squared, that would be 7 times 7. Of course, 7 times 7 is 49. So all we need to finish here is to take the value pi, a little more than 3, times 49, and we will have our area. Again, notice that they did specifically say use 22/7 for pi. And you're welcome to test this in your calculator again, but if you divide 22 by 7, you get a decimal that's roughly about 3.142, which of course then is really close to pi, and it has benefits for using this version. In this case, if we take 22/7 times 49, we should end up with an answer of 154. Of course, since we calculated area, that's actually 154 centimeters squared. Again, if we covered this circle with grid lines like we saw a moment ago, and we had to try and calculate all of them quickly, there would actually be 154 of those little squares inside of the circle. Now, some of us are still wondering maybe why we use 22/7, and the choice is relatively clear. Before we get to that, don't be too confused, ladies and gentlemen. Most of the time, you might be familiar with seeing the number 3.14, and using 3.14 is not inherently wrong. But in our big ideas practice here, you are going to be asked to use both 3.14 and 22/7 based on the situation. The situation here is simply this. When you look at the radius or the diameter, whatever they provide you with, you'll be given a value. If that value is divisible by 7, the same thing as the denominator of that fraction. If that number is divisible by 7, then you should use the fraction version for pi. 22/7. The reason is because when we were all done, we got a nice clean whole number, 154. Whereas if we had used the decimal, well, again, it wouldn't have been wrong. It just would have been a different approximation. You would have gotten what we sometimes call a messier number. You would have had a not so clean decimal. We'll do another example of finding area. Notice this time they do ask us to use 3.14 so that we don't save this unnecessarily for the end. We get to use 3.14 because the diameter, 26, is not evenly divisible by 7. You can't take 26 divided by 7 and get a whole number. Since that's not the case, there's no benefit to using the fraction. We're just going to use 3.14 instead. So to find the area of the circle, we will take pi times the radius squared. The difference here, of course, is that they didn't give us the radius. They gave us diameter. So we're going to have to review the lesson from last week about the relationship between diameter and radius. And what we know is that the radius is equal to half of the diameter, or the diameter divided by 2. So to find that radius, we'll take 26 divided by 2. And the radius we need to use is actually 13. Now we are ready to substitute in our radius into our formula. So we'll have pi times 13 squared. 13 squared is actually equal to 169, so we're going to take pi times 169. And as we mentioned already, we will use the version or approximation of pi of 3.14. And once we finish this calculation, we'll finally have our area and be all set to go. That's all there is to it. Just for clarity, it is fully the expectation, ladies and gentlemen, that you will use calculators for these calculations. You are certainly welcome to challenge yourself and do them by hand, but this is a good time to remind ourselves of how we can work smart and not necessarily overly hard here. Once you finish that calculation, you should have gotten a number about 530.66, meaning the area in this case is going to be 530.66 square inches. And that's all there is to area. Before we wrap this up, I am going to give you a couple of problems you can do on your own if you want to test yourself before you get to the assignment. So take a look at these. On your own, you've got these two problems here. Number one, find the area of a circle with a radius of 6 feet. You get to use 3.14 in place of pi. Number two, find the area of a circle with a diameter, tricky there, of 28 meters. This time you'll use 22/7 for pi. Go ahead and pause the video now if you'd like to try these ones on your own. After a few moments, the answers will appear and you can review your work to see if you'll have more questions for me before you continue. Go ahead and pause the video now. All right, here you go. Number one, you should have found an area of 113.04 square feet. And for number two, the area would have been about 616 square meters. Again, if you do end up with any extra questions, make sure you email me or reach out to me on Google Classroom. Good luck, everybody, and I will see you next time.